Hello everyone, I welcome you all for the 7th session of the chapter Ray Optics. In this session, we will be learning about the refraction through the prism. Okay. First, let us understand what is a prism. A prism is a optical medium which is having totally 5 faces. Okay. It has 5 faces. It's a 3-dimensional object. Out of those 5 faces, 2 faces are triangular and the 3 faces are rectangular faces. Let me write the diagram of the prism. You can understand it better. See, this is how a prism looks like. So totally it has 5 faces, out of which ABC, which is a triangular face, EFD, which is also a triangular face, and these 2 faces are a non-refracting faces. Okay. This face ABC is a non-refracting surface, and also the triangular surface DEF, which is also a non-refracting, and BCDE. So this surface is also a non-refracting surface. So there are only 2 refracting surfaces. The 2 refracting surfaces are this A, B, E, F, and on the other side we have A, C, D, F. So only there are 2 refracting surfaces, which are nothing but the 2 rectangular surfaces A, B, E, F and A, C, D, F, and the remaining 3 surfaces are non-refracting. Now if you take the cross section of a prism, let us take a cross section of a prism. So when you take a cross section of the prism, this is how it looks like, correct? When you take a cross section of the prism looks like this. So this is, let me say this is A and this is B, this is C. A, B, C are the 3 corners of a prism. Now let us say that this AB and AC are refracting faces. I told you that this rectangular surface and the surface which is behind it, which is a refracting one. Therefore AB and BC are refracting surfaces. Now imagine a ray of light is incident on this. Imagine a ray of light is incident on the one face of a prism, that is AB, and BC forms the base of a prism. This is for base of a prism. So imagine a light is incident at the surface AB, and here we should draw a normal first. We should draw a normal here. Let us draw a normal, and a refraction takes place here. The refracted ray moves like this. So if PQ is the incident light, then this QR becomes a refracted light. Now this refracted ray again undergoes a refraction because this AC is also a refracting surface. So at this point one more refraction is taking place, and the refracted ray, which is called as an emergent ray, which is RS. RS is an emergent ray which emerges out of the prism like this. And if you draw a normal at this point also, a normal looks like this, correct? So this is a normal which joins the first normal. Now let me say this normal is Mn and this is M dash N. Now I know that this is incident ray. This is incident ray and this is a normal. The angle between the incident ray and the normal is called as angle of incidence. And here the first refraction is taking place. At this point a first refraction is taking place, so that the angle made by the refracted ray with this normal is R1, and here the second refraction is taking place. Therefore the angle made by the refracted ray with this normal is R2. Okay, this is R2. And very importantly, when the ray emerges out of the prism, so this is the emergent ray, and this emergent ray makes an angle of E, which is called as angle of emergence. This is called as angle of emergence. So this is how the ray is going to bend in the case of a prism. Now if you see the diagram, if this is the incident ray, in the absence of the prism the ray would go like this, correct? This is the actual direction of the incident light. So the ray in the absence of the prism, so it may travel like this. But because of the presence of the prism, it undergo refraction here and also here, so that the ray is deviated from its original path, correct? This is the original path of the ray, but because of the presence of the prism, the ray is deviated like this. So, if I retrace this emergent ray backward, it will join the actual direction of incident light here. So, this is the actual direction of the incident light and this is an emergent ray. So, let me draw an angle between these two. Okay, what is that? The angle made by the emergent ray with the actual direction of the incident light. So, this is called as an angle of deviation. This is called as an angle of deviation. So, what is deviation? The ray has to travel like this, but because of the presence of the prism, it has changed the direction, so it has deviated. Therefore, the amount of deviation is represented using the angle of deviation d. So, this angle of deviation is the angle made by the emergent ray with the actual direction of the incident light. So, this is the deviation. So, if n is the refractive index of the medium of the prism and d is the deviation, and this is called as angle of the prism. Okay, this is called as angle of the prism. So, the relation between this angle of the prism, let me say this is a relation between angle of the prism, deviation and the refractive index. So, that we need to derive now. So, we need to derive an expression which is relating the refractive index of the prism, angle of the prism and the amount of deviation or angle of deviation. Now, we need to derive an expression which is relating the refractive index of the prism, angle of the prism and the deviation produced. So, for this, let me consider a prism, a cross section of the prism. This is a cross section of the prism and this AB is a surface which is a refracting one, and this AC is another refracting surface, and this BC forms the base of the prism. BC forms the base of the prism. Let us say that the angle made by these two refracting surfaces, which is called as the angle of the prism A. I said that BC is a base of the prism which is a non-refracting. Well, so we have to write the initial explanations as: consider a prism with an angle of the prism A, and AB and BC are the two refracting surfaces and BC is the base of the prism. So that initial explanation should be written. And then consider a ray of light PQ is incident at the surface AB. Okay, this is an incident light. PQ is an incident light which incident at the surface AB. And at the point of incidence, let us write at the point of incidence, first we need to write the normal, or we have to draw the normal. So a normal looks like this. This is a normal drawn. Okay. So say this is M and N. Mn is a normal drawn at the point of incidence. Now we know that the refraction takes place here and the refracted ray will move like this. Okay. So this is QR, which is a refracted ray. This QR is a refracted ray which passes through the prism like this, and at this point the refracted ray is incident at this point again. So we know that AC is also a refracting surface, therefore here also refraction takes place. So first let us draw the ray which emerges out of the prism like this, and call this as RS, and at this point we need to draw a normal again. Okay, so when you draw a normal, how does a normal looks like? A normal will be like this, correct? Let us say that this is M dash N. We have joined the normals drawn for this surface and this surface, so that this is a common point, and say this is N. Okay, Mn and M dash N are the normal drawn to the surface AB and AC respectively. Now let us write this is incident light and this is a normal at this line. So the angle made by them is equal to I, which is the angle of incidence. Angle made by the incident ray with this normal is angle of incidence. So this is a refracted ray, and the refracted ray is making an angle of R1 at this surface, and this refracted ray makes an angle of R2 at this surface. R1 is the angle of refraction at this surface and R2 is the angle of refraction for this surface. And the ray is emerging out of the prism like this. Therefore, the angle made by this emergent ray with this normal is called as angle of emergence E. This is a angle of emergence E. Now, if I write the original path of the incident light, it would go like this, correct? In the absence of the prism, the ray would travel like this. But because of the presence of the prism, the ray is deviated in this path. So, if I retrace the path of the emergent ray, what we will get is, we will get somewhere here, correct? So that the angle made by the emergent ray with the actual direction of the incident light, correct? The angle made by the emergent ray with the actual direction of the incident light, this happens to be the deviation D. Okay, this is the angle of deviation D. Now, let n is the refractive index of the prism. To derive this expression, first let me consider a quadrilateral here. So, which is the quadrilateral we need to consider? A, Q, N, R, correct? A, Q, N, R is a quadrilateral. So, for this quadrilateral, let me write for the quadrilateral, A, Q, N, R. So, in this quadrilateral, the angle A and angle QNR, correct? The angle A and angle QNR. So, this angle. So, they are opposite interior angles. Sum of the opposite interior angles of a quadrilateral is equal to 180 degrees. Okay. So, this angle plus this angle should be equal to 180 degrees. Therefore, let us write that angle A plus the opposite angle is this, which is QNR. So, that QNR is equal to 180 degrees. Okay, that is equal to 180 degrees. So, that is a very important point to be remember. So, from a quadrilateral AQNR, the opposite interior angles, angle A and this angle QNR, so that must be equal to 180 degrees. So, say that is the first equation we got. So, let me say this is the equation A we got. Next, let me look at the triangle now. What is that triangle? Triangle QNR, correct? A triangle QNR. So, for the triangle QNR, so for this triangle QNR, the sum of the interior angles of a triangle is equal to 180 degrees, correct? So, we have learned that. Sum of the interior angles of a triangle is equal to 180 degrees. So, what are the interior angles of a triangle QNR? Angle R1 plus angle R2 plus angle QNR, correct? This is QNR. Angle R1 plus angle R2 plus angle QNR should be equal to 180 degrees. Let us write that. This is angle R1 plus angle R2 plus angle QNR is equal to 180 degrees. Let us say this is equation number B. Now, if you look at the equations A and B, we can clearly write the RHS are same, correct? Since RHS are same, we can equate the LHS. Therefore, equating LHS from A and B, let us equate the LHS. So, angle A plus angle QNR is equal to angle R1 plus angle R2 plus angle QNR. So, angle QNR and angle QNR gets cancelled. So, what we get finally is angle A is equal to angle R1 plus angle R2. So, this is a very important relation to get. So, we got an expression number 1. An expression number 1 says angle of the prism is equal to R1 plus R2. Next, I know that this is the angle of incidence, correct? This is the angle of incidence and this is angle of refraction R1. A ray is incident at any surface and if this is a normal and the ray is going to bend like this is angle of incidence and this is angle of refraction. So in the absence of this medium, the ray would go like this, correct? This is the actual direction of the light, and this is what we called as a deviation, correct? So the ray, it has to travel like this, but because of the presence of this medium, the ray is going to bend. So it has bent towards this. So this is the deviation produced for this ray. Means this angle D should be equal to I minus R. I minus R, correct? And here also. You can take the same thing here. So the ray has to travel in this path, but because of the prism, it has bent towards this. So this angle is nothing but a deviation produced. Let me call that deviation as D1. And here also, this is the angle of emergence. So this is the angle of emergence. And this is the refracted ray. So at this point, let me draw an angle as D2. Let me call this angle as D2. So deviation is produced at this point, which is called as D1, and here the deviation is called as D2. So the total deviation D will be equal to this D1 plus D2. Okay, the total deviation produced for the ray will be equal to D1 plus D2. As you can see, this is an exterior angle of a triangle, correct? Look at the triangle OQR. So for a triangle OQR, this is an exterior angle D, correct? This capital D is an exterior angle. So exterior angle is equal to sum of the two opposite interior angles. So if this is an exterior angle, these are the two opposite interior angles of a triangle. Therefore, this capital D is also equal to D1 plus D2. So you can take in that way also. But the total deviation is this capital D. The total deviation is given by the deviation produced for the first incidence, the deviation produced for the first refraction, and the deviation produced for the second refraction. You can take in that way, or geometrically you can say OQR is a triangle. For this triangle, D is an exterior angle. So this exterior angle will be equal to sum of the two opposite interior angles. So D is equal to D1 plus D2. In that way you can consider. So let us write that the total deviation produced is given by capital D, which is equal to D1 plus D2. Now I said that the deviation can be written as I minus R1, correct? The deviation is written as I minus R1. I have written the diagram there, correct? So this deviation is equal to I minus R1. Let me substitute this deviation, first deviation as I minus R1 plus the second deviation. So this deviation D2, which is written as E minus R2, correct? E is the angle of emergence. So this E minus R2 gives this D2. Therefore, if I write this D2 as E minus R2, what you will get is I plus E minus R1 minus R2, or you can write the same expression as I plus D minus of R1 plus R2. So we got an equation number 2 here, so which is nothing but an expression for the D, that is deviation. Now if I draw a graph of the angle of deviation versus angle of incidence, how does the graph looks like? When we draw a graph of angle of incidence versus angle of deviation, we get. How does the graph looks like? Let us proceed. So when you draw a graph of angle of deviation versus angle of incidence, what you will get is, you will get a graph like this. So you will get a graph like this. So if you consider any value of deviation, so for this value of deviation, we get the two values of angle of incidences, correct? This is I, and somewhere here we have E. So for any value of deviation, we get the two values for angle of incidence. But when the deviation is minimum, okay, when the deviation is minimum, let me say this is D minimum. So for this D minimum, we get only one value of angle of incidence, correct? So for the minimum deviation, we will be getting only one value for angle of incidence, which means angle of incidence and angle of emergence becomes same. It has only one value. So for that minimum deviation, the ray passes, the refracted ray passes parallel to the base of the prism, and that value of deviation is called angle of minimum deviation. What is angle of minimum deviation? Angle of minimum deviation is the deviation produced by a prism for which the refracted ray passes parallel to the base of the prism. The refracted ray passes parallel to the base of the prism. So that condition is nothing but a angle of minimum deviation. As you can see in this diagram, for any value of this D, we may get the two values for angle of incidence and emergence. But at the minimum deviation, we get only one value for angle of incidence. We get this only one value. So at this condition, the deviation becomes minimum. The angle of deviation is very less. So for this minimum deviation, the refracted ray passes parallel to the base of the prism, and that angle is called as angle of minimum deviation. When we draw a graph of angle of incidence versus angle of deviation, we get two values for each deviation, but for the angle of minimum deviation, we get one value of angle of incidence. Okay? So if this condition is obeyed, we can write at this condition, we get the only one value for angle of incidence. Therefore, I is equal to E. The value of I is equal to E. And also, very importantly, the angle of refraction at the first surface will be equal to the angle of refraction at the second surface, and which is equal to R. So here, this R1 and R2 becomes same. Okay, R1 and R2 becomes same when the deviation is minimum. So let me apply the values of I is equal to E and R1 is equal to R2 is equal to R in equations 1 and 2. So what we will get now? Therefore, equation 1 becomes, so what happens to the equation 1? Angle A is equal to R1 plus R2. Since R1 and R2 are equal, A is equal to R plus R, which is equal to 2R, correct? Therefore, equation 1 becomes angle A is equal to R1 plus R2 is equal to R plus R, which is equal to 2R. So if I write the value of R, what I will get is R is equal to A by 2, correct? R is equal to A by 2. Now applying the same condition, I is equal to E and R1 is equal to R2 is equal to R in the equation 2, what you will get is the angle D is equal to I plus E. Since I and E are same, I will write I plus I minus R1 plus R2. So this is written as R plus R. I plus I is 2I minus R plus R is 2R. And this is equal to D. Now 2I minus 2R. So 2R is equal to A, correct? So this 2R is equal to angle of the prism A. So if I substitute this 2R by A, what you will get is, if I take A to this side, we get A plus D is equal to 2I, or if I want the equation for I will be equal to A plus D by 2, correct? So this is 2I. When I take the 2 to the denominator, we get I is equal to A plus D by 2. So this is I is equal to A plus D by 2. Now finally, let us write the Snell's law to complete the derivation. From Snell's law of refraction, we know that n is equal to sin I by sin r. N is equal to sin I by sin r, and we should say this is d minimum, correct? This is d minimum. Well, let us substitute the values of I and r from these two equations to get the final expression. So we will write this n is equal to sin I. Sin I is a plus d minimum by 2, or simply I can write it as a plus d by 2. This is sin of a plus d by 2 whole divided by sin r. So sin r is sin of a by 2. This is sin of a by 2. So this is the relation which is relating the angle of the prism, angle of minimum deviation with the refractive index of the prism. So this derivation will be asked for 5 marks in your exam, which is a very important one. Okay, so what are the things we have learnt in this class? We learnt about the prism. So what is a prism? A prism is an optical medium which is consisting of 5 faces, out of which 3 are non-refracting and 2 surfaces are refracting surfaces. So in the prism, if I want to derive an expression for the expression which is relating the refractive index, angle of the prism and the deviation, so we will be getting the equation as n is equal to sin of a plus d by 2 divided by sin a by 2. Okay, so that's all for this session. Thank you.